nephron goes here. Another nephron. This is proximal convoluted tubule, loop of Henle, distal convoluted tubule, and it will go here. So, a number of nephrons keep the fluid or urine into the collecting duct. It collects the fluid from the nephrons. Okay. So, these are the parts of a nephron. Now, this loop of Henle has how many limbs? 2 limbs. This is called descending because fluid goes downwards, and this is called ascending limb. So this is descending limb, of loop of Henle. This is the ascending. Makes sense? Upwards. Okay. So fluid goes like this and this. Okay. Okay. So now you know the parts of a nephron and where the filtration occurs. Okay. So you see here aorta, renal artery, segmental artery, interlobar artery, arcuate artery, cortical radiate, afferent arteriole, glomerulus, that tuft of capillary, right? Then efferent artery. Now what happens? The blood enters into 2 other capillary structures. One is called peritubular capillaries and another vasa recta. You remember at the very beginning today I said inside the kidneys how many types of capillaries you have? 3. One is, you already know, this is a capillary, right, structure. This is called glomerulus. It is a ball or tuft of capillary, right? So that is number 1. Number 2, you have peritubular capillaries, and number 3, vasa recta. So let's see what happens. So you already know this is the efferent arteriole. So efferent arteriole can form 2 other capillary structures. One is around the upper part of the nephron like this. This is called peritubular capillary. Peritubular capillary. And another is along the loop of Henle. This one is very important. Along the loop of Henle, and it looks like a ladder like this. Why? Because you see these 2 limbs of that capillary are connected by transverse capillaries like this. It looks like ladder, and that is called vasa recta. So these are 3 sets of capillaries now you got. You see the tuft of capillary is called glomerulus, makes sense? Where filtration occurs, right? And then efferent arteriole. From efferent arteriole we get 2 types of capillaries, peritubular capillaries and vasa recta, which looks like a ladder, okay, and runs along the loop of Henle. This is very important. Okay, we'll talk about that. So now you know there are 3 sets of capillaries in the kidney, and then blood enters into the vein, and veins are opposite. Just you see the names are same as arteries, but we go from small to large. We know that, right? Arteries, in arteries, arterial system, blood goes from large artery to small arteries, right? In venous system, small veins to larger veins. Okay, so cortical radiate vein, arcuate vein, interlobar vein, those are just same as the arteries. Then one thing is missing here, which vein is not here, but artery is present there. Segmentum. Make sense? So in case of veins, one is absent. That's the segmentum. That means what? From interlobar, the blood directly enters into the renal vein. Now you tell me, renal veins get out from the kidneys and enter into which large vein? Here.
The inferior vena cava.
Inferior vena cava. Make sense? Because venous blood should not go back to aorta. Aorta is artery, right? So venous blood will go to inferior vena cava. Very good. Okay. Good. So that's the blood flow in the kidney. It is very important. Okay. How many nephrons are present in each kidney? About 1 million. So now you can think how small, right? The nephrons are. But each nephron can produce urine. Here, you see, I already showed you. This is the glomerulus, afferent, efferent. This is the Bowman's capsule, okay? And this is the proximal convoluted tubule, loop of Henle, descending, ascending, okay? It should be E, okay? Then distal convoluted tubule and collecting duct. A number of distal convoluted tubule enter into the collecting duct, okay? Now, how many of you remember the pyramid? Remember? Pyramid? And this pointed part is called what? Papilla, right? Papilla. And I told you urine is secreted from the papilla, right? And a cup or funnel shaped structure is receiving that urine, that is the minor calyx. Remember that? Okay, good. So, in this papilla, in this part of pyramid, you have thousands of collecting ducts. So, all collecting ducts, okay, are together in the papilla. So this part of the nephron is in the papilla, and urine gets out because this is the last part of the nephron. So urine gets out from here. Make sense? And many last part collecting duct is ending here in the papilla. That's why urine is getting out from there. Okay. Good. Okay, now in human kidney we have two different types of nephrons. Very simple. Some nephrons have long loop of Henle and some nephrons have short loop of Henle. So those are two types of nephrons. So like this is one nephron. This one has long loop of Henle. This is the collecting duct, okay? Long loop of Henle. So this is one type. This is another type of nephron. See here. This is the proximal convoluted tubule, and this one has short loop of Henle. So these are two types of nephrons. Long looped nephrons are called juxtamedullary nephrons. And short looped nephrons are called cortical nephrons. So those are two types of nephrons present in the human kidney. Juxtamedullary nephrons or long-looped nephrons produce concentrated urine. Produce what? Concentrated urine. Cortical nephrons or short-looped nephrons is something else. Okay, I think it's okay. So short-looped nephrons or cortical nephrons are responsible for dilute urine. Formation of dilute or diluted urine. Is it clear? So which nephrons produce concentrated urine? Juxtamedullary or long looped nephrons. In human kidney, we have cortical nephrons more. 85% nephrons are cortical nephrons. Only 15% nephrons are juxtamedullary nephrons. Is it clear? Right. Now you tell me, in a camel, have you seen camel?
Yes.
Okay. Did you see? In the zoo, right? Okay. In the zoo, you have seen camels. Okay. She didn't tell it. Now you are okay? Good. Camels. A lot of camels you will find where?
Desert.
Desert. Last year I went to Dubai and Saudi Arabia.
So cool.
Here you see huge area many camels, big camels. You can ride on them.
Did you ride on them?
No, I didn't. My kids, they did. And also, they have a ride in four-wheel, SUV kind of, very fast on the sand. It's fun. I didn't ride. I was sitting and they are doing the stuff. So yeah, so camels, since they don't get enough water, right, in those areas, they need to preserve the water in the body. So what kind of urine they should produce?
Concentrated.
Very highly concentrated, right? Very small amount. So they have which kind of nephrons more to produce highly concentrated urine? Juxtamedullary, right? Much higher than human. Now you tell me, have you seen sea beaver or sea lion? They live in water, right? So they don't need to preserve water in the water. So they have more cortical nephrons, right? They have more cortical nephrons because they don't need to produce highly concentrated urine. Okay? They can easily get water. Okay, so those are two different types of nephrons. You see here, this is the picture that I showed you here. This is short loop and this is long loop. And now you can also see three types of capillaries. Tuft of capillary or ball is the glomerulus, and this is peritubular capillary, and this is vasa recta. You see along the long loop, it's a ladder-shaped capillary structure that is called vasa recta. Make sense? Okay. So those are three capillaries. Okay, now we'll talk about an important structure that is called juxtaglomerular apparatus, JGA, juxtaglomerular apparatus. What is that? You remember I mentioned that kidney has endocrine function. Remember two chemicals I mentioned, renin and erythropoietin. And at that time I mentioned renin causes what? Generalized vasoconstriction to increase the blood pressure, right? So now you know when renin should be released, when the blood pressure goes up or down? Down, because it causes vasoconstriction to increase the blood pressure, right? So when blood pressure goes down, at that time kidney should release what? Renin. Makes sense? To move the blood pressure up, increase the blood pressure, right? So from where the renin is released? We know from the kidney, but which structure of the kidney? That is the juxtaglomerular apparatus, okay? So juxtaglomerular apparatus can detect the blood pressure is going down. Make sense? Low blood pressure can be detected and secrete the renin. Okay? So detection of blood pressure and secretion of what? Renin to increase the blood pressure, right? So that is the function of juxtaglomerular apparatus. Is it clear? Okay. Now, you know, this is the ascending limb of loop of Henle. Now let's remove the other one to make some space. Okay, so this is the ascending limb of loop of Henle, proximal, distal convoluted tube. In this part, and the afferent arteriole. Now you see one thing. When we draw a nephron, you see the picture of a nephron, we always draw like this, take big area. But inside the, now think that inside the kidney, how many nephrons you have? How many nephrons in each kidney?
1 million.
1 million, right? So nephrons don't get that space inside the kidney to spread like that, okay? Everything is squeezed, make sense? Squeezed. So actually, this is just for you to, show different parts more clearly. But actually, inside the kidney, this is loop of Henle, ascending limb of loop of Henle, okay? Distal convoluted tubule, like that. So this is the distal convoluted tubule, proximal convoluted tubule, this is the descending limb, this is the ascending limb, okay? That is one. And also the arteriole. This is afferent, sorry, afferent goes like this. This is afferent arteriole, glomerulus, and efferent arteriole, okay? Now what happens is, see, inside the kidney, actually these two parts are very close to each other. The end part of ascending limb of loop of Henle and the afferent arteriole. So this is afferent arteriole and this is the ascending limb of loop of Henle. And these two structures come very close to each other, like this, very close to each other. And that is the juxtaglomerular apparatus. That means juxtaglomerular apparatus is formed by the distal portion of ascending limb of loop of Henle and part of afferent arteriole. Make sense? This is afferent arteriole, this is the distal part, end part of ascending limb of loop of Henle. Now if I make a cross section here, make a slice, okay, here, what I will see? A structure, this is what? Afferent arteriole, right, this one, and also another tube, this one, that is the ascending limb of loop of Henle together. So make a slice, I'll see these two. And in the wall of the afferent arteriole, you have special type of cells, and these cells are called granular cells. These cells secrete renin into the blood. This is capillary, this is afferent arteriole. So renin is secreted by the granular cells into the blood. Is it clear? To the blood. And in the wall of this end part or distal part of ascending limb of loop of Henle, you have the cells. Those are sensitive to the flow of fluid or urine inside the nephron. Okay? These cells are called macula densa in the wall of ascending limb. So those are two types of cells important. One type of cells, those are called granular cells in the wall of the afferent arteriole, and another type of cells in the wall of the ascending limb, distal part of ascending limb. These are called macula densa. These cells secrete renin, and these cells can detect the flow of urine through the nephron. Okay. Now, both are important. If the production of urine is less, that means less blood is going through the kidney. That is one thing. And if the blood flow here is low, that means blood pressure inside the artery is low. So low blood pressure and low flow of urine will stimulate the granular cells to release renin. This is the most important thing. Renin is secreted when the blood pressure drops or flow of urine drops. Okay, so now the pressure inside the afferent arteriole, if it goes below 80 millimeter of mercury, that pressure is the mean arterial pressure. How many of you remember MAP? All of you remember, right? Pulse pressure, you calculated MAP, mean arterial pressure, right? Diastolic, 1/3 of pulse pressure. Remember that? So, if the mean arterial pressure goes below 80 millimeter of mercury, that will stimulate the granular cells to release renin into the blood. Okay, and renin does what? I said renin causes generalized vasoconstriction. Remember that? To increase the blood pressure. But renin itself doesn't do that. Renin does what? Renin converts a chemical in the blood that is called angiotensinogen. Angiotensinogen, which is an active chemical, to angiotensin 1. Then angiotensin 1 is converted by a converting enzyme, angiotensin converting enzyme, to angiotensin 2. This is the active chemical that causes generalized vasoconstriction throughout the body. constriction of the arteries. That will increase the blood pressure. Okay, so blood pressure goes up. Okay, so that's how the renin works. It doesn't directly work on the blood vessels. It converts the angiotensinogen, which is inactive, right, present in the blood, to angiotensin 1, and then this chemical converts the angiotensin 1 to angiotensin 2. Angiotensin 2 increases the blood pressure. Okay? Angiotensin 2 has other functions too, other ways it works, but just know that here that generalized vasoconstriction. Okay? So that's how the renin is produced and works. This is just a section, afferent, glomerulus, efferent. And you see in the wall of the afferent you have the granular cells, and this is the distal part of the ascending limb. These are the macula densa cells. Okay? Now let's go here. This is just filtration membrane. You already know. This is the glomerulus, and this is the Bowman's capsule. So filtration occurs here. So now this is the membrane, which consists of these two membranes, wall of the capillary and the Bowman's capsule. So the fluid must pass through these two layers. One is the wall of the capillary, another is the wall of the Bowman's capsule or Bowman's capsule. Okay, so from the blood, fluid enters into the nephron, but it must pass through the layers, and that is the filtration membrane. Filtration membrane, through which the fluid gets out from the blood and enters into the nephron. Okay? And since the capillary is fenestrated, you see many fenestrations are present in the capillary. Now, just to know that there are three processes of urine formation. Just know the name. We'll talk these three in next class. Filtration, I have already mentioned. Another is called tubular reabsorption and tubular secretion. So when the urine passes through the nephron, tubular reabsorption and tubular secretion occur. And filtration occurs here, you already know. So those are the three processes of urine formation. Okay?
I don't remember any of that stuff either. Are you free to study model call this week?